Allow me to remind you about the laws of indices that are very common in mathematics. Laws of indices. Laws of indices that I am multiplying a raised to the power of m multiplied by a raised to the power of n. Same basis is equivalent to a raised to power m plus n. I will quantify this by giving you an example. Let's say, for instance, I have 2 raised to the power of 3 times 2. Any number written without, so this one is equal to 2 raised to the power of 3 plus any number written without a power is equal to 1. So what is this? 2 raised to the power of 4, which is equal to 16, and that is the answer. So that is it. When I am multiplying and the bases are the same, I add the powers. If I have a raised to the power m, this one is power, or this one is also what I'm calling what? The power or the index. In singular is called index or indices in plural. Then this one is the base. So whenever I am multiplying and the bases are the same, I simply add the power. The second law of indices is the division rule. So what does it say? That if I am dividing and the bases are the same, I subtract the power. So this one is equal to a raised to the power of m take away n. When I am dividing, I subtract the power. An example, e.g., I have 4 raised to the power of 3. I am dividing it by 4. So this one will be equal to 4 raised to the power of 3 take away 1. Any number written without a power, it means it is raised to power 1. So there is a 1 here. But because 4 raised to power 1 is just 4, then there is no need to write the other one. So we subtract out. What will we have? We will have 4 raised to power 2, which is the same as 16. So that is the solution for that, for this particular expression. The third power of indices. For instance, I have a raised to the power of m, everything raised to power n. When I open up the bracket, I'll have a raised to power m multiplied by n, which is a raised to power mn. A power raised to another power. When I remove the parentheses, I multiply the two powers. I will do an example for this, e.g., 2 raised to the power of 2 into bracket raised to power 2. So when I remove the parentheses, then I'll have 2 raised to the power of 2 times 2, which is the same as 2 raised to power 4. 2 raised to power 4 is the same as 16. Another rule of indices that I would want you to take note of, another rule of indices that I want you to take note of that is also very important, this one, a raised to the power of 0 says is equal to 1. Any number raised to power 0 is always equal to power 1. Therefore, e.g., if I have 5 raised to power 0, the answer is 1. If I have pi, y, x, everything raised to power 0, the answer is 1. If I have 2x, y, everything raised to power 0 is equal to 1. Any number raised to the power of 0, the answer will always be equal to what? The answer will always be equal to 1. But what about this one? If I have this, a raised to the power of m n, then this one can be written as the denominator becomes the nth root of a everything raised to the power of m. So that is how you express this. If the indices is a fractional index, then that is, you look at the denominator, it becomes the root. So for this case, nth root of a, everything raised to the power of n. For instance, I have this one, 16 raised to power, let me talk of 3 out of 2. This one will simply mean that this is equal to, I want to try and simplify this. So this is equal to the square root of 16, everything raised to the power of 3. What is the square root of 16? 4. 4 raised to power 3 is the same as 4 times 4 times 4, which is now equal to what? To 64. So that is the solution. So these are some of the laws of indices that you have to take note of, because they are very common in exams, and try as much as you can to be able to go through them, for they will help you to do it as you do your revision. Thank you for following that.